Good morning, everybody. We have our very last lesson on light that we have been talking about over the course of just a little over a week. So today we're going to hear about color, why we see different colors when we look at something. And over here I've got my color drawers with all the colors of the rainbow, or almost all of them. Now, why is it that one shelf appears purple, another blue, another red, and so on? We'll see why that is today. Now, recall that when white light contains all of the colors, remember that if we use a prism, we actually can see all of the colors of the rainbow through that prism. So white light gets separated through something like that, or a rainbow, a natural prism. Let's hear about why these colors exist according to what we see with our eyes, though. Well, and first about opaque and transparent objects a little bit more. Now, nearly all the light that hits a mirror surface is reflected. However, the surfaces of most objects do not reflect all light, and instead absorb or transmit some light as well. Light cannot pass through or be transmitted by opaque objects. Opaque means it is, like this book here, a hard surface that does not let light through on the other side of it. Instead, a shadow would form. Many of these types of objects are around us, like our clothing, our desk. Those are opaque objects. Now, some materials, like water or glass, transmit light. They allow light to come through a little bit. Do you all remember the word for something that is completely letting a lot of light in, like a window? Transparent, that's right. And what happens when we've got some light passing through, not much, you can see this kind of shadow. That's called translucent. Good job. So we've got transparent, translucent, opaque. So back to color now. Now, why does grass appear green to us, or why do clouds appear gray? Why are daffodils yellow, and why are some tulips red? The color of an object is determined by how it reflects and absorbs light. So if reflection is bouncing back, absorption is soaking in, like this black absorbs more than white. Now, the objects that we mentioned, in addition to objects around us, like the book that I'm reading from and the clothes that we wear, they're opaque objects. And they absorb, but they also reflect some light. Because these objects absorb some wavelengths of white light and then reflect others, they appear to have a certain color. These objects are not sources of light. These are not sources of light. There are man-made artificial things like light bulbs that do create light. But these ones don't do that. They do not radiate their own light or produce their own color. They don't even really produce that color. The color you see when you look at an object is actually reflected light, right? So it's not that the object itself, this part is black and kind of showing you black light at our face. No, it's taking in the color around us, taking in the light, and then reflecting back just the green to us at the back of this Math in Focus workbook. So absorbed light is sucked in by an object. Absorbed light is what we don't end up seeing to our eyes. So this green that you see on the math workbook is just reflecting back to us green, and it absorbs the rest of the colors that we don't see. So red and orange and yellow, it's absorbing all of those, and we're seeing green. Now look at some objects around you in your room. I'm looking in the classroom at what I have around me. So the colors that you see are reflected by a light source. In this case, I have some just light bulbs in the ceiling. That is what's reflecting all of the light that I have around me. Blue jeans appear blue because particles in the material reflect blue light and absorb all of the other colors of light. A sweater appears red because particles in the material reflect the red light and absorb all the others. So this shirt reflects just the black that you see, and it absorbs all the others. As a demonstration that things don't give off light, consider what a red book looks like in a pitch black room. Okay, so we were to turn off the light in this classroom. I'm not going to do that since the whole room ends up being pitch black. Well, actually, I'll go ahead and do that. Let's see the desks that you guys would be sitting at. Okay, so if I have these red lockers here, oh no, they're no longer red. They're not actually giving off red light because they need the light to reflect the red. So it's not producing light, it's not producing color. It's just reflecting off whatever that color is. So white materials, like the whiteboard over here, are actually reflecting all of the colors, and that's why we actually see it as white. So black is actually like the absence of all the other colors. Black absorbs all of the light. So, and because white contains all of the colors, it reflects all the light waves and absorbs none of it. Okay, so those are the ones that are a little different than the colors. So I have a black shirt on right now that is absorbing all of this light and not reflecting anything back. And there's a little bit of variation, so there are still some particles in certain parts of it. And then this whiteboard over here is reflecting all of it back to us. And since all of the colors combine to show you white, we can't see any one specific color. It's just all of them. So as we already learned, black ends up staying warmer because when it absorbs all of that sunlight, it changes to thermal energy. So if you are outside on a hot day, you'll feel warmer in a black shirt than you would in a white shirt because that white shirt is reflecting off. However, that still doesn't make a huge significant difference. Okay, now finally, refraction and lenses. Hopefully some of you had a chance to play around with refraction by like sticking a straw or a spoon in your glass of water. Did you guys do that recently to see the refraction? So this one doesn't, show very well. I don't have a clear glass around me. I do have this little water tank from my coffee maker. Okay. So you can even see not quite. Let me grab a knife or something. Okay, got a little plastic knife here. If I stick the knife in the water, do you see it a little bit crooked? Do you remember why that is? Okay, it gets refracted because light moves faster in open space, like all of this doesn't have water. It's a little bit more open, not quite as open as just the air up here, but it's a little bit more open. And then once it hits the water, light moves even slower. So it's slower to reflect back once it hits the water. That's why you can see kind of a crooked line there. It's still very fast in a transparent object, and this would be an example of a transparent object. Well, it's not showing as clearly as some, but I still wouldn't call it translucent. Oh, actually, this would be a good example of convex lens, because it's distorting the image behind it. Should have pulled that out in yesterday's lesson. Okay, so that is about all. Remember that convex lenses are curved out. Some of the items that might use convex lenses are like telescopes, magnifying glasses, and microscopes, because we want things to look bigger. So we use those convex lenses to make things look bigger to our eyes. Whereas concave lenses, they curve out, or basically it's like a cave and a mountain. It curves. Concave lenses, they curve in and spread light rays apart. A lot of times that ends up making things look smaller. So concave curves in and makes things look smaller. Convex curves out and makes things look bigger. So convex, once again, would be used for like a telescope and microscope. Concave to make things look smaller. Do you have any examples of that one? No, not here. So let me look that up real quick. Well, you can let me know if you see concave lenses anywhere. I'm not seeing, and I can't think off the top of my head of when we would need to use a concave mirror to make things look a little bit smaller. And then also it will sometimes flip the image depending on where you are. Oh, the spoon is a great example of that. A spoon is concave, and the point of it is not to make you look smaller, but it does. So a spoon would have, sorry, I'm a little unprepared for this. I don't have the right things necessarily with me. So a spoon, for the parts that you would dip into like a bowl of soup, is concave. It curves inward. And then on the flip side of it, it's convex. So that is an excellent way to see your reflection in a way that practices the concave and convex lenses. I would recommend you all get a spoon, like a real spoon, piece of silverware, that's silver, so that you can see your reflection with a concave versus a convex lens. Okay, that is all for today's lesson. I will talk to you all soon. Have a wonderful day. Bye.